Okay, so I want to go over the heating curve that you worked on yesterday so that we can kind of understand a little bit better what exactly we should have been seeing. So when you have a heating curve, you start at the solid phase and you start adding heat, the temperature rises. And remember that temperature is the average kinetic energy of the particles in the substance. It's not necessarily the heat that's being transferred. That's a transfer of thermal energy. Rather, it's a measure of how quickly and how much the particles in the substance or in the sample of matter are moving. So if you notice that in the very initial phase, you will have an increase in temperature, and so the particles are moving faster and faster and faster, and so the temperature is rising. But then you should get to this flat line. And in the flat line, what's happening is we have a phase change. So the temperature remains constant during the phase change because all the energy that's going into the system right now is changing phases. So at this point, we have the particles beginning to separate and change positions. And so they're becoming a liquid. This is melting, and it's a phase change here. So we don't have any temperature change during the phase change. Then after we get to where we have a fully liquid system or sample of matter, then the temperature will again begin to rise. It will rise all the way up until the point where you begin to have a phase change again. Now you notice that this phase change happened a lot quicker than this phase change. That's because the heat of fusion, which is the amount of heat needed for this phase change, is always going to be less than the heat of vaporization. And that's the amount of heat that's needed to make this change from liquid to gas. So again, we are now hit boiling and we're going from liquid to gas. And we have another flat line because again, we are having a phase change. And so particles are changing from liquid particles to gas particles. And there's no increase in the overall kinetic energy in the system. Now, once we get there and we have gas particles, then we have vaporization and the temperature again begins to rise. Okay, so flat lines are your phase changes, right? Flat lines are your phase changes. And the slanted lines are when you're having an increase in temperature. So, So if you look at this particular graph, you can see this one notes the melting point and the boiling point. Now, this graph that we looked at here is temperature versus time. This graph here is actually temperature versus the amount of heat. So you can tell in this graph that when the heat is still being added when we have these phase changes. So even though we're continuing to add heat, we're not getting any rise in temperature or any more energy in the particles because it's a phase change because the particles are changing from solid to liquid and again from liquid to gas. Okay, this one is another one that shows heat versus temperature. Something else to remember is that melting is going from solid to liquid, but freezing is going from liquid to solid. So often we talk about the melting point versus the freezing point, but for any substance, the melting point and the freezing point should be the same temperature. And again, going from liquid to gas, that's vaporization. And then going from gas to liquid, that's condensation. This would be the heat of fusion. That's the amount of heat needed to change from solid to liquid. And this is the heat of vaporization, which is the amount of heat needed to go from liquid to gas. Okay. This is another temperature versus energy chart or graph, sorry. This is heat in kilojoules, and this is temperature in degrees Celsius. So you notice that from 10 kilojoules to 30 kilojoules, we are at 60 degrees Celsius. And then from 50 kilojoules to 80 kilojoules, we are at 120 degrees Celsius. So again, noticing those flat lines of phase change, the heat of fusion and the heat of vaporization. So hopefully your graph looks like this. If not, please go back and make some changes and realize that the flat points were indeed phase changes.